Hi guys, welcome to this new tutorial. This time I want to show you how to create these effects using light functions. So what are light functions? They allow you, I'm just gonna spawn a light here. So if you scroll down here, actually you can type light function. So you have this slot here that you can assign a material. You can assign any material, but it's expecting a very specific one, which is I'm going to show you in a minute. And basically allows you to project a material or a texture onto a surface or add effects like flickering light of a fireplace or a candle. So let's jump into it and show you how to do this. Let's start from the flickering frame. Let's go to content folder. We can create a new folder. We call it um, light function, and we can create a material. We call it for master material, uh, flickering flame. Okay, let's open the graph. So now the first thing we have to do, we have to change this material domain from surface over to light function. So that gives us an emissive color. Now it's black because it doesn't have any input. So if you plug in a scalar parameter, give a default value of 1, see it turns completely white and emissive. But what we want to do, we want to add some fluctuation to simulate the flickering light. And the way we do this is by adding sine node, sine, um, and sine node, what it does, it creates like a curve that fluctuates between 0 and 1. And that requires a time node. So let's plug that in and let's test it. So you see now it changes the value from 0 to 1 smoothly. Uh, but we want to add some randomness to this. And to add some randomness, we can do it by adding a second sine node. Let's plug that in, test it again. Okay, so now it's random. Now, what is happening? It's going completely black and then white. We want to clamp the minimum value to prevent it from going completely black. And we can do this with our clamp node. Let's put that in and let's get a scalar parameter for minimum, and let's set it to 0.2, and we can leave the maximum 1 or maybe it's 1.5. Okay, so now you see it's not going completely black anymore. It stays at the value of 0.2. Okay, what is happening now, the minimum value, it stays on for a bit too long. If we want to prevent this from happening, we can do it by constant bias scale node, and that should solve the problem. Okay. Now it's a little bit too fast. Well, it really depends on the kind of fire you're trying to create, but we can control the speed by adding a parameter. So press S left click, let's call it speed, and it's doing a multiply node. Let's plug this to the B value and onto the sine node. and we can give value of 0.6, so it's a bit slower than before. And okay, that looks good. The only thing that is missing is, let's say you have two candles, one next to the other. The flickering effect, it will not be exactly the same for both. So you need to create a slight offset between the two to make it believable. And we can do that by putting a not node. And actually, let's change this to B and S left click, scalar parameter. We can call it offset. We can leave the default value at 0 because we will have control over this in the material instance for the new instance that we created for the other lights. And that looks okay. We can apply and save. And now we can go on and test this. Let's create a material instance so we don't have to get into the graph anymore. And let's add the light. 0.5 here. And the light function, we have selected the material instance, and we can go on and apply it to the slot, and that's your flickering. Can reduce the intensity a little bit, can change the light color, and if you open the material instance, you have the parameters here you can modify, and now you can see this light is flickering at the same exact rate of this other light in the campfire, and we can apply an offset of 0.5 maybe, and you see now the difference between the two. You can also change the speed, so you have a more aggressive fire, or a very slow one. It's up to you how you want to go on with this. And that's it for the flickering flame. Let's move on to the next one. This is my actual favorite. So the new material, and let's call it MM water effect. Let's open the graph again and change this from surface to light function. And okay, so now what we have to do here, we have to close this. We have to create this effect, and this is moving in 4 different directions. So we have to create a material function for this. And we can do it here in the same folder. We can create to material function, and we can call it MF four-way motion. Let's open the graph. Okay, the first thing that we have to do, right click on the graph, let's add a texture sample. And in here, this is something that you also have by default inside the engine. If you click here and search for T base underscore normal. Okay. Now we need to duplicate this texture 4 times because we need a texture for every single direction we want to manipulate. Okay. Now, the way we're gonna create movement is with a node called partner. So right click, partner, and we have to give each one a different value in order to create some randomness. Otherwise, they will be moving all in the same direction. So let's give the first one a value of 0.1 on X and Y axis. Plug it into the UV of the texture. The second one, we can give it minus 0.1 on both axes. Then the third one, we can do can do maybe minus 0.1 and positive 0.1. And then the last one, we can do the opposite, 0.1 and minus 0.1. Let's plug it into the UV of the texture. Now, this, for it to work, it needs a texture coordinates. So let's add the node texture coordinates. And we can temporarily plug it into the coordinates pin just to see how this works. And let's preview this node. Okay, start preview node. So this is only one, of course, and you can see just one movement. Just to show you, the 0.1 on both axes creates the movement in this direction. Okay, but let's combine all of them and see what happens. So you can put a node and this one to B. Put another one here. Okay, and then we add these two together with another add node. Let's preview this node. You can see here we created some randomness. Let's put it onto a plane. Okay, you see here where it's appearing something strange right here. Basically, the effect gets to a point where it clumps together and then it sort of bounces in and out, if that makes sense. So we want to stop this from happening. And how we stop this, we have to create some randomness in the texture coordinates. So let's unplug these ones. And let's add an input function. Type input, and the first one here is function input. We want to change this to vector input vector 2, and we can call it coordinates. Okay, let's connect this two. Now we can do this one straight onto the first one. We can leave this one as it is. The second one, we want to put an add node, and then we can put a constant to vector. So we have two values for X and Y, and we can plug it in, and we can give values maybe X 0.4 and 0.3 the y-axis, and we can plug this into the coordinate of the second partner node. Okay, we can basically copy paste this one and this one, and we can plug this one here and this one here, and we can change these values. This to 0.8 and 0.1 and 0.6, 0.5, just something random. Plug this one here and this one here, and now that should stop from that weird effect from happening. And yes, we have successfully eliminated that problem. Okay, now the next thing that we can do is this is a little bit too bright. And this is probably because there are four different textures combined together. So we want to reduce this brightness. And we can do this by multiply this value and create, let me disconnect this one, create input function. And let's change it to scalar. And we can also call it divisor. And we can plug it here, and we can give it a value of 0.25. And let's preview this node. And now it's a little bit darker. Perfect. The next thing, if we want to control the speed of this, we can do it by adding another function input. And a time node. And we can multiply these two together. And here we can do value of 1 by default, and plug this into time pin. Oh wait, got to change this into scalar. Okay, so 1, 2. Sorry guys, I know it's a spaghetti mess, but I will fix this later. You can take your time and make sure everything is nice and tidy, but just for the purpose of showing you how to do it, I don't need to be super precise. We can change the name of this to speed. Basically, all this function input that I've added, this will appear under the form of pins like these ones, input pins in the material function that we're going to use in the other graph. And let's plug this into here. Stop node. Okay, cool. I think we're done here. We can apply and save. Guys, always save your progress, because Unreal Engine has this bad thing that crashes all the time. So make sure you save your work if you don't want to lose it. Let's go back to this graph. Let's go to the content browser and let's grab our material function and put it here. What am I missing? I'm missing a pin. Local divisor, a speed, coordinates. I was gonna miss a very important thing. We need a reference for our texture for it to work. So we can call a texture object. Texture object is nothing too different than a texture sample. The only difference is it doesn't have all these pins. It doesn't have any input. It only has one output. And we're gonna choose t underscore base tile normal. And so we need another pin in our material function. So we can do that by adding another function input. And this time is gonna be a input texture 2D. Let's plug that in, and this goes inside the texture pin of the texture samples. Okay, save. And now we've got the fourth pin. Perfect. Okay, so now we have our material function here. We can plug this one into the emissive color. Gives us an error because it's expecting each and every one of these pin to be connected to something. S, left click, and let's call it speed. Let's give a default value of 1. Another scalar parameter that we can call intensity. And we put a value of 1 for this one too. Then this one is expecting a texture object, which I forgot to name in the material function here. So I need to rename this texture. Okay, so we can call texture object. And this time we want the actual effect, the actual texture of the effect that we want to create, which is called caustic softer. And we can plug it here. And last but not least, we need the coordinates. Texture coordinates. So we can plug this in. It's a little bit too repetitive, in my opinion, on by default. So might want to control this. So we can add a multiply node connected to a scalar parameter. Let's call it size. Let's plug it in and connect it to the coordinates. Give it a default value of 1. We can manipulate this one in the material instance, but just to show you, if you put a value of 0.5, it's going to be much bigger. So you have control over this. Let's set it back to 1, and we can apply and save. And finally, we can now test it. Let's add a new light. I use spotlights for this effect. Let's reduce the intensity to maybe 2. And let's type here light function. And I forgot to create an instance, so let's create a material instance. We'll call it MI, stands for material instance, and we can apply this one to this lot. And there you go, you have your water effect projecting onto a surface. Now obviously, we have, if you open the material function, we can have full control over what's happening here. So, for example, you want to increase or reduce the size and the speed. Okay, that looks more natural, believable, and the intensity. And feel free to play around with this as much as you want. And that's the end of it, guys. I hope you find this useful. If you did, please consider leaving a like and subscribe to the channel. If these videos end up doing well, I might consider doing some more tutorials, maybe more elaborate as well, and maybe even an entire project from start to finish. Bye now.